Alright guys, so the final few problems for the surface area and volume mastery assessment here. I'm going to run through all of these. I will probably not use the formula method since we use the formula method so much in class. If you wanted to use the formula, we would say that surface area here, because it's a pyramid, you have one base and then the lateral area, which is the faces around. Now we would then also need to know that the lateral area formula is half the perimeter times the slant height, which is a lot to deal with. Alternatively, we could just solve each face individually. So let's look at your big B, the base area. And we know it's a square pyramid. So this base of the square measures 13 by 13. So its area will be 13 times 13. Or 169, what is that, meters squared. Then we want to look at one of the lateral faces. Because if I want to find the entire lateral area, I could do that by finding one of the faces and then multiplying. So if I want to look at this triangle on the right side there, I know that a triangle's area, and let's just say big T for a triangle, is half little b times little h. So my little b and my little h have to be perpendicular. So my little b is the length of the base at the bottom of the triangle. That is 13 here. My little h is the height of the triangle from the base to the top, which here is 12. I can more easily do half of 12 than I can do half of 13. So if you're trying to do this mentally, half of 12 gives me 6. And I get 6 times 13. 6 times 10 is 60. 6 times 3 is 18. I put those together. And I get that one of those triangles has an area of 78 meters squared. Now, we don't just have one of those triangles. We actually have 4 of them. So if I say I have 4 triangles, I'm going to have to, over here, multiply by 4. That 4t will then come out to be, that's a bit much for me to trust myself on. I could do it, but I'd want to verify it. 312 meters squared. So that's my entire lateral area. This is the entire base area. I just sum those together to find the total surface area, and we get a final answer that my surface area is 481 meters squared for this pyramid. Let me know if you have any questions remaining on that. You can use the formula method. If you're using the formula method, your perimeter here would just be 4 times the 13 since it's the perimeter of that base shape. So we're now faced with another surface area problem, number 14. But here we have a triangular pyramid, which is going to change things just a little bit. I could still use that formula that we talked about from 13, but instead I'd rather, again, solve it out manually just because I'm trying to make you guys think through each individual face. We know that the base is a regular triangle, which means that each of these edges around the base are all the same. So this is also 6, and this is also 6. If you use the formula method, that would make your perimeter of the base 18, but I'm not going to use the formula method. I'm just going to start by saying big B, the base of my pyramid here, is the bottom side. So it is this triangle, and I know that the area of a triangle is 1/2 little b times little h. I then identify for this triangle what are my little b and little h. Well, my base edge here of 6, and this height right here is how tall that triangle actually is. So it's going to be half times the 6 times the 5.2. Half of 6, pretty easy, turns into 3. 3 times 5.2 becomes 15.6. And that would be centimeters squared. We now want to start thinking about the lateral area. Now the lateral area is all those faces around the side. So we have 3 of them because it's a triangular pyramid. We have this face on the front, this face on the right, and a face around the back that we can't really see. So again, I'm going to set up a big T for the area of my triangle. And I'm going to look at one of these triangles, but we'll actually use the dimensions off the front, but it's easier if I shade in that guy. So again, half of our little b times little h. Half of, well, my base here is a length of 6, but now the height for the triangle is from the base of it up to the top, and that is 13 in this case. So now half of 6 is 3. 3 times 13 I'm going to show this out really quick. So this turns into 3 times 13. 3 times 10 is 30. 3 times 3 is 9. So that's how we get that t is 39. But we actually have, let's not use red to avoid that. We actually have 3 of those faces, so I can multiply by 3 to get the entire lateral area. So that tells me now that my lateral area, again, I can break this up. 3 times 30 is 90. 3 times 9 is 27. Put those together and I get 117 for the lateral area. We now have 117 and 15.6 as my pieces of the surface area. So when I combine these all together, surface area is going to become 132.6, I believe. And it doesn't mean anything if it doesn't have a label. So our label there is centimeters squared. Alright, so when we look at this problem, the first thing we notice is that we're doing volume instead of doing surface area. Volume's actually easier. There's less involved in this process. So I don't mean to say that it is an easy process, but it is easier than surface area. The other thing that we identify that needs to set off a big alarm in my head is that this is a pyramid. So when I think about the pyramidal volume, that volume formula, well, for a prism was just big B times H. How does the pyramid relate to the prism? That is a relationship of 1/3. It will take 3 pyramids to make up the volume of an equally sized prism. So I need to figure out my big B. So let's first start by determining what's our base. Well, it's told to us it's the square. So this square right here is our base. It's got dimensions of 3 by 3, so that becomes 9. We then look at the height. The height has to be perpendicular to the base. So we see our right angle symbol right down here. Tells me that the height is 15. So then I can set up my problem. B equals 1/3 of our 9 times our 15. 1/3 of 9 is easy to do. That 1/3 of 9 is 3. 3 times 15 gives me 45. So my volume becomes 45 centimeters cubed because we're talking about volume now. And our final problem here, do not mean to hit capture because I'm not saving these, is the hexagonal pyramid. So, same formula as what we just used. That's why I started you guys with an easy pyramid. We want to use the formula 1/3 big B times H. And I know sometimes I say we don't have to use the formulas. This is one of those situations where it would be better to use the formulas. Alright, so when we go to use that formula, we got to find the big B first, which here is a bit tricky since it's a hexagon. So the first thing we want to do, hopefully you remember, is we break this up into triangles so that we can actually deal with it. We don't have, well, okay, that's not really true. Sorry if you can hear Mrs. Pettigrew, she's real loud. We don't really have an easy formula for polygons larger than rectangles. I mean, we have manipulations of formulas, but in general, it comes down to the number of triangles times the triangle formula. Because any regular polygon can be broken up into triangles. So my number of triangles here is 6. My area formula for that single small triangle will use the base and the height of that individual triangle. So that's 5 and 4.3. Now, I can actually do this multiplication in any order, but to help you guys, I'm not going to use the 6 yet. It'd be easiest to do half of 6, but since I have my handy-dandy calculator, I will do half of the 5 times the 4.3, and that's 10.75. I promise you there's not an emergency going on. That is just Mrs. Pettigrew's class. So 6 times 10.75, don't know why I wrote that again. We want to calculate that answer to be 64.5. Now some people stop there. They think they're done. We're not done. We've got a tiny bit more to do. Set up our 1/3 times that big B times the vertical height of the pyramid. This 8 is worthless. We don't need it. The 6.7 is the value that we need. And 64.5 times 6.7, then divided by 3 gives me a final volume of 144.05 meters squared. Sorry, cubed, because it's volume. Gonna fix that correctly. And most of you guys watching this will have experienced the simulation in Pettigrew's room. But if you don't know what that simulation is, my apologies for all the extraneous noise today. But hopefully surface area and volume makes a little bit more sense to you guys. Please come see me if you have any other questions or shoot me a message. I'll talk to you guys later. I'm going to go make sure they're all still alive.